Imagine a force so powerful it could darken our skies for years, alter global temperatures, and reshape entire continents. A force that has brought species to the brink of extinction and molded the very face of our planet. These geological titans have been sleeping beneath our feet for thousands, even millions of years, slowly building up energy that, when released, can change the course of Earth's history. Their power is so immense that a single eruption can eject more material into the atmosphere than all of history's recorded volcanic eruptions combined. These are not your ordinary volcanoes, these are supervolcanoes, and their story is intrinsically linked with the evolution of our planet and every living thing upon it. Today, we embark on a journey to understand these sleeping giants, their incredible power, and how they've shaped the world as we know it. As we delve into this fascinating subject, we'll discover how these massive geological features have influenced everything from climate patterns to human evolution, and why scientists around the world keep a constant vigil over these slumbering behemoths. Deep beneath our feet, these geological titans lie dormant, their massive magma chambers slowly building pressure over thousands of years. Unlike regular volcanoes, which release pressure through frequent eruptions, supervolcanoes operate on an entirely different scale. Their magma chambers are so vast, they can span hundreds of square kilometers, containing enough molten rock to fill several million Olympic-sized swimming pools. The pressure building within these chambers is almost beyond comprehension, slowly deforming the Earth's crust above them. These are not simple mountains with holes in their tops. They are vast systems of interconnected magma chambers, fault lines, and geothermal features. The complexity of these systems makes them particularly challenging to study, as scientists must piece together information from various sources to understand what's happening kilometers beneath the surface. The sheer scale of these volcanic systems means that when they do erupt, the consequences are truly global in scope. Every aspect of these giants, from their formation to their eventual eruption, operates on a scale that dwarfs human experience and challenges our understanding of geological processes. When we measure volcanic eruptions, we use something called the Volcanic Explosivity Index, or VEI, which operates on a logarithmic scale similar to the Richter scale for earthquakes. The 1980 Mount St. Helens eruption, which many consider catastrophic, was merely a VEI 5, releasing about 1.3 cubic kilometers of material. Now consider this: a supervolcanic eruption, classified as VEI 8, releases over 1,000 cubic kilometers of material, more than 800 times the volume of Mount St. Helens. This means that in a single eruption, a supervolcano can eject enough material to bury an entire state under meters of ash and debris. The energy released in such an event would be equivalent to thousands of nuclear weapons detonating simultaneously. The ash and gases released would be thrust so high into the atmosphere that they would circle the globe, creating a veil that could block sunlight for years. The impact on global temperatures, weather patterns, and ecosystems would be profound and long-lasting. These eruptions are so massive that they can fundamentally alter Earth's climate systems, triggering what scientists call a volcanic winter, a period of global cooling that can last for years or even decades. In our modern world, the sleeping giants beneath our feet have left their mark in ways that continue to shape our planet. According to NASA's Earth Observatory, we stand upon a landscape carved by forces so powerful they've created some of Earth's most breathtaking features. The ground you walk on may seem stable, but beneath the surface lies evidence of nature's most awesome display of power. Satellite imagery reveals these massive volcanic systems are not mere mountains. They are vast depressions in Earth's surface, some spanning areas larger than many modern cities combined. The Yellowstone caldera alone covers approximately 30 miles by 45 miles, a testament to the raw power that shaped our continent. NASA's advanced monitoring systems track the smallest movements of these geological giants, measuring ground deformation that can be as subtle as a few millimeters per year, yet could signal massive changes happening kilometers below the surface. The scars of ancient super-eruptions are written across our planet's face. NASA's thermal imaging satellites have revealed that Yellowstone's heat output is about 350,000 times greater than that of an average volcano, releasing enough energy each day to power a small city. The park's famous geysers and hot springs are merely the surface expression of this immense power. Beneath them lies a magma chamber so vast it could fill the Grand Canyon nearly 14 times over. This isn't just a geological curiosity. It's a window into Earth's raw power, where over 10,000 geothermal features create a landscape that seems almost alien in its beauty and intensity. The ground itself breathes, rising and falling like the chest of a sleeping dragon, with movements tracked by NASA's INSAR satellites to millimeter-level precision. But Yellowstone isn't alone. Across our planet, other supervolcanoes have left their mark in equally dramatic ways. The Lake Toba caldera in Indonesia, site of Earth's most recent super-eruption 74,000 years ago, now cradles one of the world's largest crater lakes. Its waters, stretching over 100 kilometers in length, hide the scars of an eruption so massive it may have almost wiped humanity from existence. Satellite data shows these calderas aren't just holes in the ground, they're active systems that continue to shape our planet. The Long Valley caldera in California, another sleeping giant, has been pushing the ground upward at rates of up to 3 centimeters per year, its movements carefully monitored by NASA's network of Earth-observing satellites. In our modern age, these ancient titans are watched more closely than ever before. A global network of sensors, satellites, and monitoring stations keeps constant vigil over these sleeping giants. NASA's fleet of Earth-observing satellites, including the ASTA Thermal Emission Imaging System, provides us with unprecedented views of these volcanic systems. They track everything from ground deformation to gas emissions, creating a real-time picture of what's happening beneath our feet. Every small earthquake, every subtle change in ground temperature, every minute shift in the Earth's surface is recorded and analyzed, giving us insight into these powerful geological systems that our ancestors could only dream of understanding. The landscapes we see today are just the latest chapter in an ongoing story of geological transformation. These supervolcanoes have created some of Earth's most fertile soils, most dramatic landscapes, and most unique ecosystems. The Yellowstone region alone hosts over half of the world's geothermal features, creating microclimates and environmental conditions found nowhere else on Earth. NASA's studies have shown that these regions are unique laboratories for understanding how life adapts to extreme conditions, knowledge that even helps in the search for life on other planets. The mineral-rich soils and unique geological conditions created by ancient supereruptions continue to influence where and how life thrives on our planet. In a world of skyscrapers and satellite technology, we've built our civilization atop nature's most powerful geological features, often without realizing the full implications of this coexistence. The fertile soils left behind by ancient supereruptions now support vast agricultural regions that feed millions. In the Snake River Plain of Idaho, stretching hundreds of miles from Yellowstone, farmers harvest crops from some of the most mineral-rich soil on Earth, a direct gift from past volcanic activity. These agricultural zones, born from the ashes of prehistoric cataclysms, now produce over 30% of America's potatoes and significant portions of its grain. Yet this same fertile ground reminds us of the power sleeping beneath our feet, as the very minerals that enrich our crops came from eruptions that would devastate our modern world if they occurred today. Our relationship with these sleeping giants isn't just about risk, it's also about opportunity. Modern civilization has learned to harness the immense geothermal energy these systems provide. In Iceland, where the mid-Atlantic ridge meets one of Earth's supervolcanic systems, Over 85% of homes are heated using geothermal energy. The geysers, in California, sitting atop ancient volcanic systems, form the world's largest geothermal field, providing clean energy to millions of homes. These sustainable energy sources represent a delicate balance between harnessing nature's power and respecting its potential for destruction. Every day, thousands of measurements are taken, monitoring everything from ground temperature to microscopic changes in surface elevation as we attempt to safely coexist with these powerful geological features. The same forces that could threaten our civilization also offer solutions to our growing energy needs, creating a complex relationship between human development and geological power. Our modern infrastructure exists in a complex dance with these geological titans. Vast networks of sensors, satellites, and monitoring stations form an early warning system that would be unimaginable to previous generations. The USGS Yellowstone Volcano Observatory alone processes data from over 500 seismic stations, dozens of ground deformation sensors, and numerous gas monitoring sites. This information flows through high-speed internet networks, enabling scientists worldwide to collaborate in real time. Major cities like Tokyo, Naples, and San Francisco have developed extensive evacuation plans and building codes specifically designed with volcanic and seismic activity in mind. Every aspect of modern urban planning in these regions must consider the sleeping giant beneath, from the depth of building foundations to the materials used in construction. These landscapes have become critical intersections of tourism, science, and cultural heritage. Yellowstone National Park alone attracts over 4 million visitors annually, generating over $642 million in local economic benefits. The tourism industry has grown around these geological wonders, creating jobs and driving economic development in regions that might otherwise remain sparsely populated. Research facilities built near these sites employ thousands of scientists and support staff, while also advancing our understanding of Earth's processes. Universities have established specialized research centers dedicated to studying these geological features, creating hubs of scientific innovation that attract minds from around the globe. The very presence of these supervolcanic systems has shaped not just our physical landscape, but our economic and intellectual landscape as well. The economic relationship between modern civilization and supervolcanic landscapes extends far beyond tourism and research. Insurance companies now factor supervolcanic risk into their global catastrophe models, influencing everything from property values to international investment strategies. The World Bank estimates that a major supervolcanic eruption could cause global economic damages exceeding $10 trillion, more than the combined GDP of many nations. Yet these same regions drive significant economic activity through mineral extraction, agriculture, and energy production. The challenges of monitoring and preparing for potential volcanic activity have spurred technological innovation, creating new industries focused on geological monitoring, risk assessment, and disaster preparedness. From satellite technology to advanced seismic monitoring systems, our need to understand and coexist with these geological features has driven scientific and technological progress worth billions of dollars annually. Throughout human history, the awesome power of volcanoes has shaped not just our landscapes, but our very understanding of the world. From ancient creation myths to modern scientific endeavors, these geological giants have left an indelible mark on human culture and society. Indigenous peoples across the Americas have lived alongside Yellowstone's supervolcano for thousands of years, incorporating its geothermal features into their spiritual beliefs and cultural practices. The Tukudika people, also known as the sheep eaters, developed unique hunting techniques and tools adapted to this challenging landscape, demonstrating humanity's remarkable ability to thrive in the shadow of Earth's most powerful geological features. Their stories and traditions, passed down through generations, speak of both respect for and harmony with these powerful forces of nature. offering modern civilization valuable lessons about sustainable coexistence with these geological wonders. In our contemporary world, supervolcanoes have captured the public imagination in ways that transcend scientific interest. Hollywood blockbusters, documentary series, and countless books have attempted to portray the awesome power of these geological titans, sometimes with accuracy, other times with dramatic license. This cultural fascination has created a unique challenge for scientists and educators, balancing the need to maintain public awareness without falling into sensationalism. The influence of supervolcanoes extends into literature, art, and popular culture, inspiring everything from apocalyptic fiction to philosophical discussions about humanity's place in nature. Museums worldwide house exhibits dedicated to these geological wonders, drawing millions of visitors eager to understand both the science and the spectacle. These cultural interpretations serve as a bridge between scientific understanding and public awareness, helping society grasp the significance of these natural features in ways that pure data cannot convey. The presence of supervolcanoes has fundamentally shaped educational and research institutions in regions where they exist. Universities near these sites have developed world-leading geology programs, attracting students and researchers from across the globe. The influence extends beyond geology into fields as diverse as archaeology, anthropology, and environmental science. Local schools incorporate volcanic science into their curricula, creating generations of citizens who understand their unique geological heritage. This educational impact ripples through society, influencing career choices, research priorities, and public policy decisions. The presence of these geological features has created communities of expertise, where children grow up understanding concepts like geological time and volcanic processes as naturally as they understand weather patterns or seasonal changes. Living near a supervolcano has profoundly influenced how communities organize themselves and plan for the future. Cities and towns in these regions have developed unique emergency response systems and community education programs. Local governments maintain complex evacuation plans, regularly updated based on the latest scientific data. But perhaps more remarkably, these communities have developed a distinctive cultural identity, one that embraces rather than fears their geological neighbor. Festivals celebrate geological heritage. Local businesses incorporate volcanic themes into their branding, and community events often center around education and awareness. This adaptation shows how human society can transform potential threat into cultural strength, creating resilient communities that understand and respect their environment. The societal impact of supervolcanoes extends into the realm of human psychology and collective behavior. Research has shown that communities living near these features often develop a unique form of geological awareness, a kind of cultural DNA that influences everything from architectural choices to family emergency plans. This awareness has spawned new forms of citizen science, where local residents actively participate in monitoring and research programs. Social media networks and community forums buzz with discussions about the latest geological data, creating an informed and engaged populace that serves as a model for other regions facing natural hazards. These communities have developed what scientists call geological literacy, an intimate understanding of their environment that goes beyond basic knowledge into a form of cultural wisdom.